Okay, let's unpack this. Ever wish there was like a shortcut?
A shortcut.
Yeah, a way to just grab the essential knowledge from, complex tech fields
Yeah.
without drowning in documentation.
Ah, like an instant expert button.
Exactly. Like for something like software-defined wide area networking, SD-WAN.
Mm-hmm.
Well, that's pretty much what we're doing in this deep dive. Our source material today, it's a set of topics and practice questions.
Huh?
They're designed for the FCSS SDW AR 7.4 certification exam.
Right, so real-world focus.
Yeah, think of these questions as like spotlights. They point right at the knowledge experts think is most critical.
Gotcha.
Our mission: extract those core concepts, those essential nuggets from these sources, give you a serious head start on what really matters.
It's a practical approach, definitely. I mean, looking at what's in assessment materials, it gives you a clear view
Rory, of what?
of the fundamental principles, the
Mm.
practical applications, the stuff that's key for actually understanding and working with these technologies, in the real world.
Agreed. We're going straight for the vital insights. So, where do these questions start us off?
Well, naturally, with the basics.
Right, the foundations.
Exactly. We were talking basic SD-WAN setup, understanding members, your WAN links and zones.
And performance SLAs, gotta have those.
Crucial.
Yeah.
These are the absolute building blocks. You can't really build a robust SD-WAN overlay without a solid grasp of how to bring your interfaces into the fabric
Makes sense.
and defining those performance targets. The service level agreements, SLAs,
Mm-hmm.
they determine if a link is actually, usable for your apps.
Right. And speaking of usable, the source material jumps right into directing traffic. Like, one question looks at the preferred member setting in an SD-WAN rule.
Ah, you're
What
right.
does that actually do?
That setting is, well, it's where you start adding the intelligence. The preferred member lets you specify a link
Okay.
that traffic matching the rule should try to use first. But, and this is critical,
Mm.
it only uses that preferred link if it's meeting the performance criteria.
The SLA criteria you set.
Exactly. The criteria you defined in the SLAs for that specific rule.
Ah, okay. So it's not just blindly forcing traffic down one pipe. It's more like, I like this link best if it's performing well enough right now.
Precisely.
That feels like a core part of the whole software-defined idea, right? Ensuring apps use the best link available at that moment.
Mm-hmm. Even if that means dynamically shifting away from the preferred one, if it degrades.
Okay.
And that leads directly into the next foundational concept they highlight, link health monitoring.
Right. Another question focuses just on that.
Yeah. Why is constantly measuring latency, jitter, packet loss on each link just, well, non-negotiable?
I guess it's about making those dynamic decisions smarter. You can only switch to a better link if, in real time, which ones are better.
You're exactly right. Link health monitoring is the engine. It drives the intelligent decisions.
The engine, okay.
It actively probes each link, gathering that real-time performance data against your SLAs. Without that constant monitoring, the SD-WAN just wouldn't know, would it?
Know if a link went bad.
Right. Or if latency spiked, or if it dropped below the threshold for, say, VoIP traffic. It's how the network maintains reliability and performance dynamically.
Okay, that makes sense. So foundation is know your links, set performance goals, SLAs, monitor health, make smart choices with rules, maybe prefer a link if it's good.
That's the core loop, yeah.
Got it. Now, the exam topics, they seem to ramp up pretty quickly. More advanced territory, hub and spoke IPsec, AD VPN, multi-hub, multi-region setups.
Yeah, this is where it gets really interesting, where SD-WAN goes beyond just simple link aggregation.
Building complex, resilient overlays.
Exactly. And AD-VPN, Auto-Discovery VPN is a prime example. It's designed specifically to make those big hub-and-spoke or mesh networks more efficient.
Okay, and one of the questions dives right into an AD VPN setting. Auto-discovery receiver.
Mm-hmm.
The source explanation says this allows dynamic spoke-to-spoke tunnels via the hub. Can you break down why that's such a big deal?
Absolutely. Think about a traditional hub-and-spoke VPN setup. If two branches, two spokes need to talk, their traffic has to go all the way to the hub.
Right, hairpinning.
Exactly.
Right.
Traverse the hub, then go back out to the other spoke, adds latency, puts a huge processing load on that hub device.
And as you add more spokes talking to each other, that hub just becomes a massive bottleneck.
Totally. So what AD-VPN Auto-Discovery does, it lets the spokes, after they register with the hub, learn about the other spokes' public IPs.
Okay.
Once they know how to reach each other directly, they can dynamically build a direct IPsec tunnel between themselves, a shortcut tunnel.
Bypassing the hub completely for that specific traffic flow.
Right.
So the auto-discovery receiver setting is what lets a spoke accept those shortcut tunnel requests from others.
That's the one. It enables that dynamic connection.
That's a huge efficiency gain, especially for, like, branch-to-branch voice or video.
Oh, yeah. Drastically cuts hub load, improves latency for that spoke-to-spoke communication, which is, critical for a lot of modern distributed apps.
Yeah. Makes sense. Now, those dynamic shortcuts, they don't need to stay up forever if they're not used, right? Another question covers the 80 VPN idle timeout.
Good point. Resource management comes into play.
What's the thinking behind controlling how long an unused shortcut tunnel hangs around?
Well, keeping every single potential spoke-to-spoke tunnel active constantly, that would eat up a lot of resources, wouldn't it?
Yeah, I suppose so. Memory processing.
Precisely. Every active IPsec tunnel uses memory and CPU cycles. The idle timeout lets the system automatically tear down a dynamic shortcut if no traffic's gone through it for, a set period.
Configurable period.
Yeah, it's just housekeeping, really. Keeps the tunnel table clean, frees up valuable system resources, essential for performance and stability as your network grows.
Efficient resource use. Got it. And scaling up definitely brings challenges, especially in those complex multi-hub or multi-region 80 VPN designs.
Oh, absolutely.
A question about multi-hub setups mentions route tags, says they can influence which shortcut gets selected. How do route tags fit in?
Okay, this is where you get into granular control in complex scenarios. Imagine a multi-hub environment. A spoke might learn routes to a destination through multiple hubs.
Right. So how does it choose?
Well, without anything else, standard routing metrics usually decide. Path, cost, distance vector stuff.
But maybe you don't want the standard choice. Maybe app A traffic needs to go via hub 1 for a specific security service.
Exactly. While other traffic, maybe less critical, can go via hub 2 for, say, direct internet access.
So route tags let you do that?
Yes. Route tags are basically non-standard BGP attributes you can attach to routes as they're advertised. In a multi-hub 80 VPN setup, you can use these tags in your routing policies or even your SD-WAN rules to influence path selection.
So you could say, traffic from this source to that destination, prefer a route with tag service hub A, something like that.
Precisely that. It lets network architects build really sophisticated traffic steering policies based on business intent, not just, which tunnel popped up dynamic.
Okay, so route tags add a layer of policy on top of the dynamic tunnels in those bigger, more complex designs. Makes sense. All right, we've talked about building the network, optimizing it. The next big piece is managing it all, right? Especially across loads of locations.
Centralized management, yeah. Tools like FortiManager.
The exam topics cover deploying from FortiManager using various templates.
Centralized management is absolutely critical for scaling SD-WAN. Seriously, manually configuring hundreds, potentially thousands of devices, it's just not practical.
And super error-prone, I bet.
Totally. Templates are the cornerstone of automation here.
Okay, so one question looks at provisioning templates in FortiManager. What kind of settings does that template handle?
A provisioning template. Think of it for the fundamental system-level stuff.
Like
when a device first comes online or gets pulled into FortiManager, setting the host name, basic network interfaces, IP addresses, default gateway, DNS servers, all that basic plumbing.
the stuff that gets the device connected and identifiable on the network.
Exactly.
Got it. So the basic identity and connectivity for the box itself, getting it provisioned consistently before you layer on the SD-WAN magic.
You got it. And that consistency across devices is huge.
Why is that so important at this stage?
It just simplifies troubleshooting and ongoing management massively. If every device is set up slightly differently, diagnosing issues becomes a nightmare.
I can imagine.
Provisioning templates ensure all your devices start from a known standard baseline, reduces configuration drift, cuts down deployment errors.
Makes total sense for scale and sanity. Then there's another template type they highlight, SD-WAN overlay templates.
Right. Different focus.
What's their specific role?
So while provisioning templates do the device basics, overlay templates are specifically for configuring the SD-WAN and VPN parts.
Ah, the actual overlay network.
Yeah. Setting up the IPsec tunnels, the secure underpinnings defining the SD-WAN members, which interfaces are participating.
And the SD-WAN rules themselves.
And the core SD-WAN rules, yeah. The logic that dictates how traffic gets steered based on performance or whatever criteria you set.
Okay, so provisioning sets up the box. Overlay builds the secure, intelligent fabric on the box. Logical split. And one question points out you can combine templates, like system templates, which I guess is similar to provisioning, and CLI templates.
Yeah, system template is often used interchangeably with provisioning template for those core device settings.
Okay. So what's the benefit of mixing, say, system and CLI templates?
Flexibility, really. System templates give you a structured way, often UI-driven in the manager, to set up common stuff. But sometimes you need to apply very specific commands.
Things not in the standard options.
Exactly. Maybe less common settings or advanced configs that just aren't exposed in the standard template interface.
And a CLI template just lets you push raw command line commands.
That's it. It's like the automation escape hatch. By combining them, you get the best of both worlds.
Oh, so.
Use the structured system template for the bulk of the standard config, then use a CLI template to inject those precise custom commands you need for a specific scenario or, some advanced feature.
Detailed automation without being limited by the standard GUI stuff.
You got it. It offers really detailed, flexible automation.
That flexibility sounds pretty essential for real-world deployments with diverse needs. Okay, we built it, we managed it centrally. Now, keeping it running smoothly, fixing things.
Troubleshooting and resilience, yeah.
The exam topics cover troubleshooting rules, routing, AD/VPN.
Network resilience is paramount in SD-WAN, right? You're relying on multiple links. Things will occasionally go wrong with one of them.
It's inevitable.
How the network handles those disruptions automatically, that's key.
So a question about BGP stability during an interface failover points to using update source loopback.
Ah, classic.
Can you explain why configuring BGP that way keeps the session stable when an interface dies?
Yeah, this is a fundamental routing best practice, really relevant in SD-WAN. Normally, a BGP session sources from the physical interface IP it peers over.
Okay.
If that physical interface fails, that IP is gone, BGP session drops.
Makes sense.
But a loopback interface is virtual. It's always up as long as the device itself is running. Its IP address is reachable as long as there's any active route to it.
Through any other working interface.
Exactly, any physical interface. So by sourcing BGP from the loopback, the session's health isn't tied to one specific physical link.
Ah, I see. So as long as the router can still reach the other BGP peers loopback, maybe via an alternate SD-WAN path, the BGP session just stays up.
Precisely. It decouples BGP peering from the underlying physical state, maintains routing stability, which is crucial for control plane resilience, especially in dynamic environments like SD-WAN where link failures are, expected.
That's a really important detail, keeping things stable during brownouts or full link failures.
Yeah.
Okay, finally. Troubleshooting those dynamic AD/VPN tunnels we talked about. One question highlights a CLI command. Diagnose VPN tunnel lift.
Your best friend sometimes.
Why is this command so helpful when AD/VPN shortcuts are acting up?
Well, it's usually your first stop if you suspect a problem with a dynamic shortcut. AD/VPN involves, multiple negotiation phases to actually bring up that tunnel.
Right.
If traffic isn't taking the shortcut path, the tunnel might not be forming right, or maybe it's stuck somewhere in that process.
So this command gives you visibility into that process.
Exactly. Diagnose VPN tunnel list shows you all the active IPsec tunnels on the device, including those dynamic AD/VPN shortcuts.
What kind of info does it show?
Vital stuff. Source and destination IPs, tunnel status, is it up? How long it's been active, and crucially, the status of Phase 1 and Phase 2 negotiations.
Ah, the IKE and IPsec SA status.
Right. Seeing that output immediately tells you if the tunnel you expect to be there is there. And if its foundations are solid, it quickly points you towards the problem.
Like a Phase 1 authentication issue, or maybe a Phase 2 policy mismatch.
Or maybe the tunnel isn't even trying to build. It cuts through the complexity and gets you to the diagnostic steps faster.
Super helpful for those dynamic tunnels. It honestly feels like we took that shortcut we mentioned at the start.
Getting right to the core.
Yeah, getting right to the core of what's important in this complex area, just by looking at what the source material emphasizes.
And it's interesting thinking about how much of this relies on automation, dynamic behavior.
Yeah. Where are you going with that?
Well, given the increasing intelligence, the automation we're seeing built into these modern networks, what does this actually mean for the role of the network administrator, going forward? How will managing these complex distributed networks continue to evolve? And I suppose what skills will become the most important?